Tennessee's at-home learning series for math. Today's lesson is for all 5th graders out there, though all children are welcome to tune in. This lesson is the second in our series. My name is Miss Williamson and I'm a 5th grade teacher in Tennessee schools. I am so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find it at www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of our others, but it might be more fun if you go back and watch the other lessons first, since we will be talking about things we have previously learned. Before we get started, you will need the Student Packet Lesson 2, or if you don't have that, you can use paper, pencil, and something to write on. I will give you a moment to get those things gathered. All right, now let's recall how to add fractions with like denominators. On your paper, I want you to write 1/3 plus 1/3. Can you solve that? Hopefully you said 2/3. If you recall, we add our numerators, 1 plus 1 is 2, and we keep the denominator the same. I can model that as well. I have a whole. It is cut into 3 pieces. 1 out of 3 plus 1 out of 3 equals 2 out of 3. I want you to try another one. This time I want you to do 1/4 plus 1/4. Did you get 2/4? Once again, we can model that. Our whole has how many pieces? It has 4. How do we know? Because the denominator is 4. Our first add-in is 1/4. Our second add-in is 1/4. When I put those together, I get 2/4. Do you notice any other way we could potentially write 2/4? Did you say 1/2? Look, if I draw a line down the middle, instead of having 2 out of 4 pieces, I can think of it as 1 out of 2. 2/4 and 1/2 are equivalent. Now I want you to try this next one. Solve 1/5 plus 2/5. And this time I want you to draw a model. Go. Did you partition your model into fifths since the denominator was a 5? Did you shade 1/5 to represent your first addend and 2 additional fifths to represent your second to get a sum of 3/5? Good. One more with a like denominator. I want you to solve 3/7 plus 4/7. Go. Your whole needs to be cut into how many pieces? 7. Your first add-in is 3 out of 7. Your second add-in is 4 out of 7, which gives us 7/7 or 7 out of 7. Can you think of another way we could write 7/7? Did you say 1 whole? That is right. Remember that any number over itself, 7 over 7, 4 over 4, 3 over 3, those all equal 1. Now let's begin using unlike denominators. I'm going to erase my board. Can you write down the expression 1/3 plus 1/2? 1/3 plus 1/2. You will notice this time that our denominators do not match. And remember, the denominator tells us the number of pieces in the whole. So this whole is going to have how many pieces? 3. Let's show that. This denominator has a 2, meaning it's going to have, I apologize, let's write those the same size so we can see the value is different. Let's go this way, and let's cut that one in half. How many should we shade in for 1/3? We need to shade in 1 out of the 3. How many should we shade in for 1/2? We need to shade in 1 out of the 2. What do you notice about the size of the pieces? Hopefully you notice that the thirds are smaller than the halves. Remember we said when you take a cake and you cut it into 3 equal pieces versus a cake cut into 2 equal pieces, you're going to get a bigger slice with the 2 pieces. So the reason we can't add these the way they are is because I can't take this piece and move it over here. It will not fit. So I have to find a way to get them to be the same size pieces, which means they'll have the same denominator. So how do you think we could do that? Well, I notice that I can take this model and cut it this way, and now I have 6 pieces. I can take this model and cut it into 3, and now I have 6 pieces. Are they the same size pieces now? Yes, they are. I want you to write the equivalent fraction for each of these below your model. Did you get that 1/3 was equivalent to 2/6? Did you get that 1/2 is equivalent to 3/6? So remember, last time we learned that we can use a model to find equivalent fractions. Now, can I add these fractions? Yes, I can, because this is equivalent to this is equivalent to this, but now we have equal size parts. So 2 pieces plus 3 pieces equals 5 pieces out of the 6 pieces you need to make a whole, or 5/6. I can show that by moving either these pieces here, or let's move these this time. 1, 2. The sum is 5/6. We also talked about another way we could do this. We could do this by using multiplication. We said in our last lesson that I could use a model, or another strategy we could use is multiplying the numerator and the denominator by the same number to create an equivalent fraction. I noticed that 3 can be multiplied to get 6. I noticed that 2 can be multiplied to get 6. And so if I multiply 3 by 2, I get 6. But remember, to keep it equivalent, I have to also multiply the top. So an equivalent fraction is 2/6. Same thing here. What can I multiply by 2 to make it 6? 3. 3, which gives me 3, 6. So whether I use the model or I use multiplication, I can create an equivalent fraction so that I can get a like denominator to add those. I want you to try another one. This time I want you to do 2/3 plus 1/4. That is 2/3 plus 1/4. I want you to keep in mind, we cannot add these the way they currently are because our denominators are not alike. Go. Okay, let's model 2/3. If I model 2/3, how many pieces should my whole be cut into? 3. The denominator tells me there are 3 pieces in the whole. On my fourths, how many pieces does my whole need to be cut into? The denominator tells me it's going to be cut into fourths. Now let's look. I want to shade in what we know. We know 2/3 that we have 2 out of the 3 pieces. So I'm going to shade in 2 out of those 3. Over here on my other add-in, I'm going to shade in 1 out of the 4. Remember, it is not possible for me to take this piece and move it here because they're not the same size pieces. So I have to ask myself, how can I get the same size pieces? Or how can we get a like denominator? I want you to jot down for a moment. I want you to take some private think time. What do you think that you could do to get equal size pieces? Did you notice that I could partition my thirds sideways? And now I have 12 pieces. I could partition my fourth 3 times up and down, and now I have 12 pieces. Both of them are now 12ths. So this was, well, it still is, represents 2/3, and this is 1/4. But below it, I want you to write the equivalent fraction we created. Two-thirds is equivalent to 8/12. 1/4 is equivalent to 3/12. Now that I have equal size pieces, I can add these fractions. 8/12 plus 3/12 equals 11/12. Remember, that's not the only way we can get a common denominator. We also, in our last video, said we can find equivalent fractions by using multiplication. So I can write 2/3 plus 1/4. We already know from our model that they can be made into what? 12ths. So if I multiply 3, what do I have to multiply by 3 to get 12ths? 4. But I have to be careful because in order to keep it equivalent, I have to multiply both the numerator and the denominator by that number. That is 8/12. What do I have to multiply by 4 to get 12ths? 3. That is 3/12. So 8/12 plus 3/12 is 11/12. Those are both 2 methods that we can use to find equivalent fractions in order to find the sum of them. Now let's do a few more practice problems. I want you this time to solve 1/8 plus 3/4. 1/8 plus 3/4. What method did you use? Did you use a model? Let's start there. Let's model 1/8. That means my whole will need to be cut into how many pieces? 8. The denominator tells me my whole is going to be cut into 8 pieces. My second fraction says the whole is going to be cut into how many pieces? 3/4 says I'm going to be cut into fourths. Now, let's model that number. How many should be shaded in for 1? All right, so how many would we shade in for 1/8? We would shade in 1 out of the 8. What about for 3/4? 3 of the 4. Remember, we cannot add these the way they are because they are not equal size pieces. So I want you to take a moment and I want you to think about what would you do to get equal size pieces. Some of you may have used the strategy we used in the past. Take the 8s, cut them into 4. 1, 2, 3, 4. Now we have 32 pieces. How many out of 32 are shaded in? 4 out of 32. Those are equivalent fractions. You may have done the same thing on the other side where you cut it, the 4ths, 8 times. How many pieces do we have now? 32. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 out of 32. Can I add these now? Yes, because we have the same size pieces or we have a like denominator to give us a sum of 28 over 32. Some of you may have noticed some things a little bit different about this problem. I'm going to redraw this. Remember we had, and I apologize that it's over to the side, I'm running out of space here. Remember I had 1/8, so 1, 2, 3, 4, 5, 6, 7, 8 pieces and fourths. 1, 2, 3, 4. We had originally shaded in 1 of the 8 and 3 of the 4. Some of you may have recognized that instead of cutting them into 32 to get equal sized pieces, that I can make fourths into 8s. How? Well, I have to cut those, each of those in half. Now that I have equal sized pieces, this is worth 1/8, and this is worth 1, 2, 3, 4, 5, 6 eighths. I can find the sum. 1/8 plus 6/8 is 7/8. What can I say about 28 over 32 and 7/8 based on what I know about equivalent fractions? Did you say that if the sum of 1/8 and 3/4 can be 28 32nds, and the sum can be 7/8, that I can conclude that these two right here are equivalent fractions? They are. Just one method, we cut our pieces into 32. We cut our fraction into 32 equal pieces. Using the other method, we cut them into 8 equal pieces. Now, I want you to try another one. This time, I'm going to pause and give you time to solve, and then we will go over together. I'd like you to solve 1/6 plus 1/3. You may have started with a model. Your first model, you would have cut into 6 pieces because your denominator was 6. Your second model would have been cut into thirds because your denominator was 3. On your first one, you would have shaded in 1 out of 6. And on your second fraction, you would have shaded in 1 out of 3. Hopefully you drew the conclusion that these cannot be added the way they currently are because the pieces are not the same size. I can't move this, it will not fit into there. So how could we get equal sized pieces? Some of you may have done what we started with. You may have decomposed this into 3 equal sections, and you may have decomposed your 1/3 into 6 equal sections. Now both models have how many pieces? They have 18 pieces. So 1/6 is equivalent to 3/18. And 1/3 is equivalent to 1, 2, 3, 4, 5, 6, 6/18. Can we add now? Yes, we can. 3/18 plus 6/18 is 9/18. Now what I want you to do is I want you to take these 6/18 and I want you to move them over here, because remember we're putting them together. So let's show that. Move these 6/18 over to this model. I'm going to use blue to show that I'm moving this other addend over. 1, 2, 3, 4, 5, 6. Knowing what we know about equivalent fractions and using this model, can you think of another way that I could write 9/18? Let's look. If I drew a line down the middle, do I have 2 equal parts? Let's check. There are 9 up here and 9 down there. Are they equal? Yes, they are. So instead of 9/18, I could say that 1 whole chunk out of 2 are shaded in. So 9/18 is also equivalent to 1/2. Now there's another strategy we could have used on this problem. Some of you may have recognized that thirds can become 6. So let's do that. That'll save us a little bit of time if we recognize that. Let's look. So once again, really quickly, I am going to model those numbers. Cut into 3, cut into 6. That line's a little crooked. 1, 2, 3, 4, 5, 6. That one's a little crooked too. All right, and so we have 1 out of 6 and 1 out of 3. Now, if I cut each third in half, we now have how many pieces? We now have 6. Remember, this goes back to what we did in lesson 1. When we cut it in half, that's like multiplying our fraction by 2 over 2. Remember, it stays equivalent as long as you do the same thing to your numerator that you do to the denominator. So I could say, I don't need to change this. It's already 6 pieces. So I'm just going to bring it down. It is worth 1/6. Now, 1/3 is now cut into 6. So instead of 1/3, we have 2/6. Now can we add these fractions? Yes, we can. 1/6 plus 2/6. Let's move it over. Move over 1/2/6 for your sum of 3/6. This is very similar to the last problem. How else could we write 3/6? Well, look at that model. How much of the rectangle is shaded in? 1/2. Very well done. Very well done. So today we practiced adding fractions with unlike denominators. You sure did a great job. You will have some problems to practice on your own. Good luck and do your best. Join us again tomorrow. We will talk about another strategy for adding fractions. I hope to see you then. In case you don't have the packet at home of practice problems, get your pencil ready and jot those down. I would like you to use equivalent fractions to find the sum and solve 2/5 plus 2/3. That's problem number 1. And 3/5 plus 2/3. That's problem number 2. Remember, in order to solve these, you will have to use one of the strategies we used today to find an equivalent fraction. You can do that by drawing a model, or you can do that by using what we've learned about multiplying fractions. Just remember, if you're going to multiply, you have to remember that you must do it to both the numerator and the denominator to keep them equivalent. Boys and girls, I have enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you on the next lesson at the Tennessee at Home series. Thank you and bye.